get started. Thank you everyone for joining. So this is a ComfyStream Contributors Workshop, and some people that are on the call today might have either caught the ComfyStream User Workshop earlier this week, if you are a part of the Comfy UI Real-Time Hackers cohort that Livepeer is running, or you might have caught something along the lines of this presentation on the Livepeer Open Ecosystem call during the community section. This one is going to be similar to those two presentations, but more geared towards anyone that's actually interested in potentially contributing to or steering the direction of this ComfyStream project that we'll talk about today. It's very much meant to be a community project, so in the interest of sharing knowledge and getting people up to speed about like what this is, how I initially thought about it when I took a pass at setting this up. I hope that it can be useful. So we'll dive right in. The first part will be pretty quick. It's going to be an overview of what ComfyStream is exactly. So if you have seen that part, feel free to tune out. But afterwards, we'll cover some new material, most notably a quick rundown of what it's like using ComfyStream, and then a little bit about architecture so that people have a sense of what's happening under the hood. So to kick things off, I think everyone here is familiar with the fact that we have lots and lots of open models these days. So you can pull down image generation model, a video generation model, and language models too from all over the internet. Something that has been of interest to me, and I know that has been of interest to a lot of the people on this call, given that this is being hosted in the Livepeer Discord, is what are the implications of using these open models on not only video, but video streams. So if we wanted to do some more real-time interactive experiences, if we wanted to use these new generative models in the context of live streams, how would we do that? Status quo, you'd probably end up using something like FFmpeg or GStreamer. For those that are not familiar, basically multimedia Swiss Army knives that can take any arbitrary video and then run some compute on the video frames. In FFmpeg, the unit of compute you can think of as filters. GStreamer, the equivalent is plugins. In both cases, these are complex tools, and if we wanted to, say, use multiple machine learning models on the frames of the video using FFmpeg, we can ask Claude, and Claude will spit out a whole lot of code. And we can definitely use this code, but it's complex. It's not exactly clear if I'm a fresh newcomer here, how I would incorporate new models, how I would compose different models together. Same thing with GStreamer. We can ask Claude, we get a whole lot of code, but it feels like maybe we can do a little bit better, or maybe we can play around with a more intuitive, friendly user experience. So I think everyone here is probably familiar with Comfy UI. So Comfy UI being probably the most, if not one of the most popular tools in the open source AI space for running mainly diffusion models, so image and video, but now increasingly being used to create a whole lot of different workflows that combine different models together, different components. And the neat thing is that you can do all of this within a graphical editor. So we have code under the hood, but for many users, their experience with Comfy UI is just connecting all these different nodes in this graph on the left together, and then just seeing what happens when you play around with your inputs, when you play around with combining different nodes together, and you're starting to see this rich, diverse ecosystem of custom nodes. So custom nodes are contributed by users, and they contain new models, they contain new types of compute that you can incorporate into your workflow. So the way that I thought about ComfyStream was an attempt to try to answer this question of what does Comfy UI meets video streaming look like? And ComfyStream today is primarily a package for running image-to-image Comfy workflows on video streams, but it also includes some tooling like a server and a UI that you can use that uses the ComfyStream package under the hood in order to run these Comfy workflows and then see how the Comfy workflows can influence real-time updates to a live stream, i.e. from your webcam. So some of the things that you could get started doing with today are real-time depth estimation. So you create your workflow in ComfyUI and then you run it in ComfyStream, and now you can see real-time depth maps being created for your webcam. You can do real-time background blur and removal, create the workflow in ComfyUI, and then when you drop it in ComfyStream, now you can remove the background from your live webcam. And then you can also do stuff like portrait animation. So for folks that have seen the live portrait model, you can create that workflow within ComfyUI, and then when you drop it into ComfyStream, you can run this on a real-time webcam feed. So that's a really quick overview of ComfyUI plus video streaming equals ComfyStream. And just to give people a taste of what this looks like, this is a couple steps that I walked through for the user workshop earlier this week. So I'll run through this really quick, but really what I want to show is what it looks like to use ComfyUI to create a workflow and then export that and run that within ComfyStream. So let's hop into that. So I have a remote GPU instance running, and I have ComfyUI running here. If I hop into my browser, I have ComfyUI running, and for those that have seen the graphical editor, this should be pretty familiar. Let me clear the workflow so we can start fresh. So this is going to be pretty simple, nothing too fancy. A lot of people here have probably done way more interesting things than this, but let's start off by loading an image. That's the first thing we'll need to do. And let's say we want to load this arcane image that I have locally. And for this demo, we'll do a very basic blurring operation because we might want to do real-time blur on our webcam feed. So I have this Gaussian blur node. This is actually a custom node that is from this node pack that I created. It's pretty similar to a bunch of other custom node implementations that involve blur within the ComfyUI ecosystem. The main reason that I added this new one is because I wanted to make sure that it runs on the GPU and not on the CPU. And that turns out and ends up being important for these real-time workflows because speed is of the essence. To the extent that we can make sure these individual operations run faster, the better, because we want to get to as close to real time as possible, if not real time, so we can get that snappy, smooth experience for our live stream. So we're going to connect our image with the Gaussian blur node. And then all we're going to do is preview the image, which is just going to show us, hey, what does the image coming out the other side look like? And then if I run it, there you go. We have a blurred version of the guy on the left. You can also do stuff like increase some of the parameters. I won't go through what the parameters do on this presentation, but the point is you can sort of mess around and see, hey, what does this do? Okay, so if I crank up the sigma parameter here, it seems to drastically increase the blur effect. If I crank it back down, it decreases. Cool. So that seems to work. And now we want to run this on a live video stream because we're interested in video streams, not just static images. So what's going to happen is we're going to basically run this over and over again on every single frame of a video stream. And in order to do that, we're going to first export this. Make sure to export it in API format, which is what ComfyStream understands. Let's call this Blur Contributor Workshop. I go to my downloads folder. You can see I have this JSON file here, and I have this JSON file here. So we're going to use that momentarily. All right, so I'm going to close. Well, actually, I don't even need to close this. Let's hop back into the okay. Eric says we aren't seeing the screen. Okay, thank you.
What are you trying to share? Sorry, I see the arcane one.
Okay, but you don't see like my folder here.
Correct.
You see this?
Yeah.
Okay.
We do not see that.
Give me 1 second. I think I'm sharing with the wrong option. I'm guessing you still don't see my downloads folder.
Now we see it. I see the downloads folder.
Okay, you see the downloads folder and you see the arcane screen.
Yeah.
Okay, I must have checked the wrong option. Sorry about that. So brief recap, we now have image-to-image workflow for blurring within Comfy UI. In my downloads folder, I've exported the workflow as a JSON file, and that's going to be something that we need to take over to ComfyStream. So if I pop back open my terminal, and I head on over to this window, let me make it a little bit bigger so it's not tiny. I'm going to run a ComfyStream instance, and this is the server that I mentioned earlier, and under the hood, this server is using WebRTC for communication, and it's basically going to be responsible for receiving a video stream from the UI and then sending back the output video stream to the UI. Hopefully this works. So I have a local UI running, and a couple things to note here. The stream URL by default, if you're running this locally, this doesn't matter because it should default to localhost and you don't need to worry about this. In this case, I'm running the UI locally, but the server is running somewhere else. So we just need to make sure the stream URL maps to where that server is. So in this case, I'm running the server at this IP on this TensorDoc service, and it is exposing the port 10518. Frame rate, this by default will be 30. You might want to play around with this, and I can talk about later where this might be relevant, but basically some workflows can run really fast and can support an input stream of 30 FPS or higher. Some workflows are going to be slower, so you wouldn't be able to process a 30 FPS stream in real time. So you might want to play around with this. The camera, we can select the camera, so one of the devices has access to. We'll just use my default camera here, and we'll ignore the OBS virtual camera option. And lastly, we pick the workflow. So if we pop open to downloads, we can open up this workflow file that we just exported. We can select start stream, and then you can see that things are starting up. And there we go. So now we have the output stream coming back. So hopefully you can see this, and all the stuff I'm running doesn't interfere. But on the right, we have the original webcam footage. On the left, this is a live feed that is processed using that Comfy UI workflow that we just created. So instead of it just being for a static image, we can run this on a stream, and it's running per frame, so we get this blurring effect. And this is neat. This is a very basic thing, right? It's just blurring, but you can imagine whatever you want to do to the frames of your video, it's just in the scope of your workflow. So if you want to do something more fancy, you can do it. If you want to do something more simple, like blurring, you can do that as well. And it's as simple as those 3 nodes that I just showed. All right. I'm going to stop that there and then jump back into the presentation. I see a question. There is some minimal delay. Can you run something more advanced? You can do something more advanced. I won't show that demo right now, just in the interest of time. But you could do stuff like depth estimation and the portrait animation stuff that I talked about. So I kind of leave that to the audience to experiment with on their own. But in the interest of time, I want to go over some other things in this talk. And I see Ryan's typing. Ryan's been doing some interesting stuff there as well, so you should definitely check out Ryan's work. He's been doing some really neat interactive stuff with Stream Diffusion. So I'm going to jump into architecture now, and I think after I'll go over these architecture sections, and I want to make sure that we can just open it up for free-form conversation. But the reason I want to go over the architecture section is just because given that this is for anyone that might be interested in contributing, I want to touch on some like high-level concepts that might be relevant here. So the 4 topics I want to make sure to cover are workflows and custom nodes, per frame, image-to-image workflows, this runtime, in quotes, and quirks. So workflows and custom nodes, the reason I want to cover this is the rough way that I'm thinking about this right now is that we can think of the Comfy UI workflows and their corresponding JSON descriptions as sort of quote unquote the language. So similar to how a programming language has its own syntax and conventions, we also have syntax and conventions for a Comfy UI workflow as well. So on the left, this is like a visual depiction of the workflow and the language. And on the right, we have a more, call it code and machine understandable interpretation of the language, i.e. in JSON. And similar to a programming language, we have custom nodes, which we can think of as the packages. So on the left, you see Comfy UI has this kind of emergent registry system for keeping track of packages. And a package might look something like the screenshot on the right. So this is my background edit node pack, and you can find it on the registry, but it's just one of many custom nodes that you can find that are out there that are created by anyone. No one is stopping you. There is no like asking for permission. It's you want to create something that does not exist in your workflow or people aren't using in their workflows yet, feel free to do so, and then people can pull it in afterwards. So quite similar to programming languages where we have rich package ecosystems. And I think this is interesting because we have the language and we have the packages, and that actually to me is the most important thing. What prompted like much of this work is how can you take this new language and these new packages and kind of reappropriate that to be useful in, say, a video streaming context. And the way that's being done right now is like so. So on the left, we have this screenshot of the workflow that we just created. We're just doing a simple Gaussian blur. On the right, this is kind of reductive and is missing a bunch of details, but roughly speaking, this is what you would expect to happen for anything video streaming related. You have an input video stream. It goes through a video decoder so that you could transform the video into input frames. It goes through a video filter step, where when we say video filter, it can mean any sort of computation that you want to run on the input frame. And then it feeds an output frame to the video encoder, and then the video encoder basically just packages it up so that you get an output video stream on the other side. And that is the thing that you see in your video player at the end of the day. So if you're watching YouTube, if you're watching Twitch, that is the output video stream. And here, we're just saying the video filter is literally the workflow that we just created in Comfy UI. We created it using this language, using these packages from the language, and we did that using a graphical interface, and we basically transformed that into a video filter. And at the code level, if you're using ComfyStream, the actual code that is taking care of all of this is simply ComfyStream And with that single call, we're basically encapsulating everything that I've described here. This workflow, that is our language, that references a bunch of custom third-party packages. All of that is a single unit that we're then invoking on the input frame using a call to ComfyStream client.
Also, Yondon, are you seeing chat or?
Yeah. Taking a look now, thank you. So, okay, so that was per image. or per frame image-to-image workflow. And before I jump into runtime, take a look at the questions. So you mean transforming the stream visually in real time, similar to how image diffusion models work, trying to figure out the use cases with the current processing speed. I think this is in reference to Ryan's comment about stream diffusion, and I see him typing, so I'm sure that he'll have his own response to this, but my quick 2 cents here is I believe that is what he's referring to, and stream diffusion allows, I guess the simplest conception of stream diffusion is that it's a technique or framework to run diffusion models faster, but because we can run those diffusion models faster on images, that also means that we can run those same diffusion models on the frames of individual videos. So we basically take an image to image model and it becomes per frame, like a frame to frame model in the context of a video stream. So that's just my quick 2 cents, but I'll let Ryan and Define kind of continue the conversation, and then maybe we can jump back as that conversation progresses. Yeah, I mean, since we paused there, any other kind of immediate questions that I'm missing here?
Question for me, and this is maybe tangential.
Yeah.
I don't know if it's relevant, but when you're talking about these nodes, what is the kind of process on that? I assume that's like much more technically complicated than just like running Comfy UI.
So the question is, when I say nodes, are you referring to, is the question around how you would create a new node?
Yeah, I mean, maybe just to give people visibility who are in the audience, just like, because you have the Comfy UI and you said you created the, blurring node because it's, you optimized it. Is that something that only people who are like super technically advanced can do, or is that something that like anybody can try their hand in?
Got it. Yeah, thanks for clarifying. That's a good question. So short answer is it is more technically involved in order to create a custom node. I think the assumption here is that if you are creating a custom node, you have some level of programming experience, and whether that means that you are someone that has been programming a long time, or it might mean that you just have been messing around with ChatGPT and Claude and you're used to generating a bunch of code. I think either option is valid, and you've seen people within the Comfy UI community come from both backgrounds. But the most important thing is, yes, there's an expectation that code is being written. And just to give you a sense of what this looks like, I think the full scope of like how to create a node is probably out of scope for now, but we can certainly talk about that separately. But I would recommend just going to the Comfy UI docs and using their docs as a starting point where they talk about, hey, what exactly is a custom node? And it also walks through what it would look like if you wanted to create your own custom node. And their tutorial does something pretty basic. And if you wanted to get a sense of what kind of like normal, like not too complex custom node looks like, so this is like a background edit package or node pack that I created, and it contains a few nodes. So in the README, you can see that it contains these three: background color, composite, Gaussian blur. So the blur operation node that I showed before is, yeah, it's not too complex. It's 42 lines of code. Most of it is just defining what the input parameters are, what the output parameters are. It does make use of certain other libraries that take care of the more complex part. But you can sort of expect nodes to look something like this, where you want to define your inputs, define your outputs, and then after that, it's pretty similar to just regular programming. The one thing I would note there is regular programming, but with a more call it like machine learning flavor. So you don't necessarily need to, if you're just gluing stuff together, you don't necessarily need to be like someone at like an expert researcher that is training models, but you will need to familiarize yourself with some of the libraries in this space. But I'll probably leave that for a kind of separate conversation. But hopefully that gives people a rough sense of, that the within custom node, like how it is something with an expectation of programming. If all you're doing is like creating workflows, like back here, then you can just stay at the graphical editor level.
Mm-hmm.
But if you want to do like, if you're missing something and you want to implement something on your own that someone else in the community hasn't done, yeah, then you'll need to kind of get your hands a little bit dirtier with code level things.
Thank you. Yeah, I just want to give people a sneak peek in case they're hungry for more. Thank you.
Cool, great question. All right, let's move on then. So back to the slides. This is getting a little bit more into the weeds of how ComfyStream works, so might be of interest to some folks, less interesting to other folks, but just to give people a taste of how things are pieced together, I'll go through it. So I have this runtime slide, and by runtime, I'm basically referring to what actually happens when you have the workflow, that JSON file that I presented, and you give it to ComfyStream. Like, how is that being run? Is Comfy UI being run under the hood? Is something else being run under the hood? The JSON file looks familiar, but ComfyStream is this separate thing. So what's the deal here? And today, what's happening under the hood is actually ComfyStream uses this fork of Comfy UI it's from these folks called Hidden Switch. So it's pretty much the same as Comfy UI, but the main thing that it has that the main version of Comfy UI doesn't, that is useful for ComfyStream, is that you can actually run this as a library. So you can see here hopefully you can see on the GitHub, this is basically the main thing that we want. We want to be able to run Comfy UI as a library inside of another Python application without mucking around with additional infrastructure and servers. Now, that's not the only way to do this, and I've listed some alternatives that were considered. So we could run literally Comfy UI as a kind of client and a server. There's also this third-party tool called ComfyScript, which, without getting into the nitty-gritty details, it's basically this tool that allows you to convert a workflow into code. So if you look at this, workflow, there is basically a tool out there that says, I'm going to convert this load image thing into actual Python code, this Gaussian blur node into Python code, and this preview image node into Python code. So that was a potential alternative as well. I initially decided to just use this fork of Comfy UI just solely out of expediency and simplicity. This is not to say that the other alternatives don't have their own merits, but from let's get something working inside ComfyStream as soon as possible and just kind of start experimenting, this seemed like the easiest initial path. And I wanted to mention that because that leads to, the future. What would this look like? Because we can imagine, should ComfyStream be dependent on a fork of Comfy UI? What happens if the fork gets updated at a different rate than the main Comfy UI? Or what happens if you run into issues with the fork as more people start experimenting with workflows that are unexpected? And I think all those are really valid and important concerns, and that's why, for the future, the good thing is that the use of this fork under the hood is, just a decision and a point in time. And there's a couple candidates to be considered in the future. So it ranges from something that I believe the Comfy org team, while they're not prioritizing today, might be prioritizing in the future, which is actually make Comfy UI a first-class kind of library that such that you don't have to rely on a fork in order to get something like that into your code. There was the Comfy script thing that I mentioned earlier. That could also be an option, although it's a little bit more complex, and you have to figure out like whether it has everything that is needed for these video streaming workflows. And then lastly, I think another option is, if you recall that I mentioned thinking about the workflow as the language and the custom nodes as the packages, there is also the option, if ComfyStream and generally using Comfy UI workflows for video streaming becomes more popular, then maybe that justifies custom runtime. So what this would mean is, hey, we have the same language, we have the same packages, but you're basically swapping out the backend, so to speak. So the engine that actually takes the language and takes the packages and knows how to execute it in a sane and in a way that makes sense. So if you are familiar with programming languages, for those in the crowd, I suppose this might be something similar to retaining your like grammar or like structure of your language, retaining the same packages, and then just having a different compiler backend. And then your compiler backend just does some stuff without changing the interface for anyone. So for users, it's all the same. But it knows how to kind of massage everything into a format and to execute it in a way that is performant, efficient, and maintainable. So that could also be an option. But that also requires a lot more work and effort. So I kind of see something like that as, hey, start with experimentation first, and then if it makes sense to go down that route, you can always kind of evaluate as you go. Okay, I just went through a lot. Pausing and taking a look at the chat. Yep, next year we'll probably have GPUs embedded in our brains. I look forward to that. I'd probably save a lot of money by doing that and stop paying these GPU clouds and stop paying NVIDIA. All right, okay, no additional questions. So let me round it out by finishing this set of slides. So quirks. This is an early stage project, so it is not going to be without its share of funky things that might surprise you, but I want to mention the main quirks here that might be surprising to you, but I want to explain, why they exist right now, and then for those that are interested in contributing, you can either take a look at these quirks and say, oh, that makes sense to do, I get what you're trying to do there, or you might say, maybe there's a better way to do this, and that would be great. So let's go through the main two I have here. So number one is prompt conversion plus load tensor and save tensor node. So in order to illustrate what this means, let me jump into the actual ComfyStream repo. So if you go to the ComfyStream client, you can see here that there is this set prompt function. And don't worry about all the other details here. The main important thing is there is something called convert prompt happening to the input. And if you go to ComfyStream utils, what does convert prompt do? Once again, we don't need to go through all the nitty-gritty details, but the important thing to note here is this convert prompt is basically taking the workflow. And the main reason I use the term prompt here is within Comfy UI parlance, I'm just adopting what other people have done. So when we're talking about the workflow within the UI and as a file, it's a workflow. But as far as I can tell within the Comfy UI code base, from a programming standpoint, they just refer to the entire workflow as a prompt. So I will do so here as well, just for clarity and consistency. So the convert prompt function basically is going to transform the input prompt and do a couple things and then spit out a transformed version of it. And the main thing that it does, that's important to take away here, is that it's going to look for any load image node or any node that loads images, and it's going to replace it with what's called a load tensor node. And the load tensor node is a part of ComfyStream. And you could think of this as, swap as being responsible for doing a specific thing, which is when we load an image in a Comfy UI workflow, it's going to look for some file that exists. And it's going to read that file and then load that image so that you can see it within your editor and the rest of the workflow can use that image. In a video streaming context, we don't really want to do that because if you did that, you would basically be like writing every single frame of a video stream to some storage location, some disk, and then writing it and then reading it and then doing that over and over again, which wouldn't be great because we care about latency, right? We care about speed. We want to actually minimize the number of extra things that we're doing that are not just the necessary compute. So the load tensor node is, you could think of as just like a very simple node that will, instead of loading the image from a file, it's going to allow the user of ComfyStream to just give it a tensor that represents an image. So a tensor is the basic data type in Comfy UI. It's basically just a multi-dimensional array that represents the image. And when we say we replace image loading with tensor loading, we're just saying, hey, anywhere the workflow is loading an image from a file, don't load it from a file. Allow the user to just give the image directly as a tensor so that the workflow doesn't need to keep on reading stuff from files. Similarly, for saving images or previewing images, typically in Comfy UI, by default, that's going to actually write the image to a file somewhere. But we also don't want to do that in a video streaming context, right? We actually want to kind of spit out the image to the video encoder. So if you go back here, we want to give the output frame to the video encoder, not write it to some file somewhere. So the save tensor node is basically doing the same thing on the output side. So every time a workflow includes this operation where it needs to save an image, instead of saving it to a file, it's just going to basically make it available to the ComfyStream user instead, so that that image can then be written, so that image can then be passed to some video encoding process. And that's really all that the prompt conversion step is responsible for. And really, you can just think of it at the end of the day as we take something that works in Comfy UI, and then we basically swap out the loading and saving steps for images so that it's more efficient for a video streaming context. So that's the first quirk I wanted to make sure to cover. Before covering the second quirk, let me take a look at the chat. So, all right, there's some conversation about ComfyStream being used as a lib. All right, so the question is, can ComfyStream be used as a package? The answer is yes. Really, ComfyStream, I think of ComfyStream as the package and the library. And the server and UI that we've demoed before are just kind of auxiliary tools that use the ComfyStream package under the hood. So if you go to the repo, everything under source/ComfyStream is basically the package. It's actually pretty simple. And then everything under server and UI are just auxiliary tools. So server, most notably, is just a WebRTC server implementation that is a wrapper around ComfyStream. So you can actually see, where is it? In this pipeline file, we're actually importing the ComfyStream package and using it in the context of this server implementation. So the best way to think about it might be ComfyStream is the package, but we also have a kind of ComfyStream server and also ComfyStream UI, but all of it's built on the ComfyStream package. Hopefully that answers the question. Next, can you use hidden switch directly instead of ComfyStream to improve delay? So that's a good question. I think there are a couple parts to it. You can certainly use the hidden switch fork directly instead of ComfyStream. Yeah, you can absolutely do that. Whether that would improve delay, I doubt it. And the reason for that is the ComfyStream implementation is really simple. And it's not trying to do anything like fancy in addition to what the hidden stream fork does. I think the best way to think about it is it's just a very thin wrapper around the hidden switch fork to provide a more convenient interface for someone that wants to integrate this type of Comfy UI workflow as video filter operation into their code. So if you look at this file that has ComfyStream client, there's not much there, right? There's a couple things happening, and then the most complex thing is this queue prompt function, and only that is a couple of lines. And outside of the prompt conversion step, there isn't really much else there, at least at the moment. And there could be more stuff included here, but my thinking and my philosophy for kind of like what makes sense here is use the hidden switch fork or the Comfy UI as a library technique in order to actually run the workflow. But everything on top are these abstraction layers to make things very dead simple to drop into any video streaming context. So just to illustrate that, if you go to the server and go to pipeline, this is what a quote unquote pipeline looks like for the WebRTC server. So we have this predict function, and it's just calling the ComfyStream client with a single line. And then everything else around that is just a small conversion step and a post-process step in order to change data formats. But everything for running an operation on a frame of video is just encapsulated into a single function call. And that function call, I would say the main addition there is just making the interface simple without having to worry about other Comfy UI related details. So that was my thinking. And once again, like if you want to use the hidden switch fork directly, you certainly can. The thinking around ComfyStream is just, hey, how do you make it more convenient to integrate in a video streaming context? Okay, we have 10 minutes left and one more question. Let me just get to this question before wrapping up. So, is the tensor exchange between ComfyStream and Comfy UI happening via map or a byte stream, i.e. is the tensor being represented as a byte stream or something else to be passed from one process to another? That's a good question. So it's not happening via map. There is no inter-process communication here actually. So, and this is only possible because we're using it as a library as opposed to doing something different. So if you go back to, if you go back to the ComfyStream package, there is this tensor cache file, and it basically maintains this queue of inputs and this queue of outputs, and all of this is in memory. And this is then used by our load image and save tensor, load tensor and save tensor nodes. And the load tensor node is basically loading that from shared memory, that tensor cache from shared memory, and then popping from the queue. So it accesses the input here. And then for save tensor, it's similarly loading this tensor cache from shared memory, and then it's popping from the output queue. And if you go to the client, the only thing the client is responsible for is, hey, I've received the input image tensor from somewhere. I'm going to append it to the input queue on the tensor cache. And then I'm also going to create in Python this async IO feature. So basically this representation of some future value. I'm going to add that to my output queue. And then I'm going to call queue_prompt on the ComfyStream client or on the underlying Comfy client. And then the expectation is that the output from that workflow is then going to be returned and set on that output async IO feature that we just appended. And then we can just await that here. So there's no kind of like inter-process extra communication happening here. That would certainly be more complex. It's a pretty simple, just in-memory kind of cached input and output queue right now. So hopefully that answers the question. I'm going to wrap up the slides because there's only like 2 more. And then I'll get to the rest of these questions. So, okay. Actually, in the interest of time, because I think the questions are interesting, I'm going to skip over this last work. We already talked about limitations. And then, yeah, that basically wraps up the kind of very basic architecture overview I wanted to cover that hopefully people found useful. It's a super early project, so beware of dragons. For bugs and feature requests, just create an issue in the GitHub repo, and then there should be a discussions tab in the GitHub repo now too. So for general discussion, you can feel free to jump in there. And I didn't include it here, but generally, if you're interested in kind of working on stuff in this area and you have ideas around this area, do feel free to message me as well. So that's it. I'm going to stop sharing my screen now. And we have a couple minutes left. So I want to make sure that we can go over some of these other questions. Is there a plan to add audio processing or text processing in addition to image processing we saw today? Can you share a bit more in terms of timeline when these might come? So I'll answer the second question before the first one, just because I think answering the second one will make more sense after the first one. So in terms of timeline, when these might come, yeah, just to be completely transparent and frank, like created this project a few weeks ago, there is no kind of concrete roadmap right now. Kind of my personal main intention has just been to support some of the work that folks are doing in the ComfyUI real-time hacker cohort that Livepeer is running. But outside of that, there is not a concrete roadmap at the moment. That might change if other people want to contribute as well and have thoughts on like where this work can go, and I certainly welcome that. But don't have a concrete roadmap on that front yet. So sort of letting this experimentation happen first, and then based on that, yeah, that might change. Is there a plan to add audio processing or text processing in addition to image processing we saw today? So yeah, I mean, as I mentioned in my previous answer, no immediate plan on my end, but on the audio processing front, I know someone from the Livepeer team, from the Livepeer Inc. core team is working on audio processing support. I believe their use case is for doing whisper transcription, and I've been following along with some of the progress in the draft PR, and yeah, perfectly doable. I think it's really just a matter of kind of getting through the implementation hurdles that are there right now. So I foresee that coming soon. And text processing, no one's working on this right now as far as I'm concerned, as far as I know. But Yeah, that could be possible as well. I think image processing is just the first. Image processing is the first focus, was the first focus, because the reality is that is the majority of the activity within the Comfy UI ecosystem today. So it made sense to start with that. But other modalities could make sense as well. But I think I would just take into account, hey, what is the level of activity with, what are the prospects of activity from kind of the cohort of people that you expect to experiment with that. Do you see any limitations to the image-to-image workflow assumption besides lack of audio support? So one thing that I don't think would work well right now, but I don't think it would be too far out to. I don't think it would be that complex to adapt the current solution in order to support it, if desired, is being able to easily run workflows where you have an input frame, but then also conditioning or auxiliary inputs that change over time. And what I mean by that is, as an example, there was a Stream V2V workshop earlier this morning for folks in the Comfy UI real-time hacker cohort. And one of the basic ideas introduced there was that you want to run the diffusion model on every single input frame, but you also want to kind of keep track of you also want to keep track of kind of data extracted from frames in the past as well, and then basically feed that data from past frames as an input into your model when you're generating the next frame. So in that scenario, you would have to make sure that your workflow not only takes in an input image, but it can take in these auxiliary inputs as well that might change over time. And the most basic version of that is already supported today. So you could do, so live portrait is another example where you have your input frame, which is each frame of the video, and you have your auxiliary input, which is like the image that you're animating. So that's supported, but it's easy to support because the input image, the auxiliary input is not changing. It's not dependent on other stuff that's happening in your workflow. But in the Stream V2V case, it's a little bit more complex because your auxiliary inputs aren't static. Your auxiliary inputs might actually depend on other stuff that you've done in your workflow on previous frames. So that's a little bit more complex, and I don't think would be supported well right out of the bat, right out of the gate right now. But I see no reason why it can't be supported. It's just a matter of doing it in a clean way that isn't really confusing for someone to integrate. And I see Eric had a follow-up question about, this feels like the topic of state management in the real-time workflow. Yeah, I think that's right. It's the current kind of ComfyStream setup is kind of assumes sort of this like stateless process. And then once we introduce this notion of you need to keep track of some state and then feed state back into the workflow in order to execute on future frames. Yeah, I think state management is probably a good way to capture that at the highest level. Couple others. Define interested in contributing on text and audio support. That's great. Welcome ideas and thoughts on how to best accomplish that. And yeah, Ryan's doing some really interesting work in his real-time nodes repo around state management. And yeah, I think that is probably going to be a good jumping off point to start tackling this question. Because today, it's great that you can do these like more simple stateless workflows and just run it on every frame. But I think, if anyone attended the Stream V2V workshop this morning for the real-time hacker cohort or has been following along with the latest and greatest in what folks are doing on the AI research side, I think two trends that we'll probably see converging more and more over time and becoming more popular is this type of like real-time stuff where you're returning frames as they become ready, but also systems for intelligently conditioning the generation of the next frame based on what you've seen in the past. So not too dissimilar from large language models, if people are familiar with the context window idea. So I think we'll probably start seeing more stuff that revolves around that, and I suspect that will make all of this state management stuff more important. Okay. Do you see a way for ComfyStream users to experiment with some of the new open source video models as they get faster? LTXV comes to mind, and Hunyuan is improving quickly. Yeah, so there was actually a conversation about this in the workflows channel that I added a comment on, and this was my quick reaction, and I certainly welcome people's thoughts on whether it makes sense, whether or how feasible it would be. And I won't go through step by step, but the TLDR is, I think the existing video models probably wouldn't work well with these types of streaming workflows right out of the bat if they return video frames as a batch. So for example, LTX is supposed to be like pretty fast, but if it accumulates the frames generated and waits until they're all ready before returning them, then that probably wouldn't work well for a streaming workflow because you're generating the frames quickly, but you're not able to pass those frames to a downstream component until later. And that would just like cause a bunch of like weird jittery delays and stuff. But what could be neat is if LTX return each frame as it's ready instead of batching it together, then you might be able to turn an image to video workflow into a kind of streaming version by doing something like you start with an initial image and then LTX gives you each frame as it's ready, and then that gets encoded into your video stream. And then when LTX is done, you take the last LTX output frame and then use that as your next initial image. So you're basically chaining image to video sequentially over and over again so that LTX basically generates frames 1 through 10 for your initial image. And then once you get frame 10, you pass that back into LTX in order to generate frames 11 through 20, something like that. I don't think that would work right out of the box today because of the batching issue. But, if someone has experience with this stuff and wants to see if it's feasible, I think that'd be a cool thing to try, where if you could get each frame as it's ready, then you could sort of like loop these image to video models and make them into, kind of like endless image to video processes. It's basically like another way to think about it is right now we're doing image to image, and then this would just be doing image to multiple image. And yeah, I think that could be an interesting area of experimentation so that you can take these image to video models and make them streaming friendly too. But not non-trivial work there. But if folks are interested in that, I think that could be like a cool thing to try. I see we're already 5 minutes over. I think we covered. Yeah. What about thinking of things as a series of image to video workflows? Yeah. I think I guess we kind of converged on the same thing. Yeah, and I think we're probably good to wrap there. Maybe like any additional conversation, we kind of kick it to Discord.
Yeah, I'm thinking for folks either in Lounge or AI research, if you want to jump into those channels, you can continue the conversation there. But Yondon, thank you for the amazing workshop, and excited for what's to come. And for those who are in the the Comfy UI Hacker Program, more to come next week as well. Yes, it is recorded. I'll get that posted as soon as we wrap up here, and that will be on the YouTube channel. And I can post that. I can cross-post that again in the Lounge under Builders. Anything else, or are we good to go, everyone?
Good on my end. Thanks,
Awesome.
folks, for the good questions and for entertaining the rambling.
No rambling, all amazing, intelligent comments. And
All right.
so awesome. Okay, Yondon, thank you so much again. And we will see you in the digital space in the community. Bye, y'all.
All right. Take care.